So now talking about resistors. So we talk about resistance, and I'm going to state that resistance is the opposition to the flow of electric charges. So you take note that we have, maybe you have a transformer, for example, and you are distributing light to so many persons, so many places, and you don't expect everyone to use the same appliance. Neither do you expect everyone to use, maybe someone is using hot plates, then someone else is using a gas cooker. Let me just say someone is using electricity in one way or the other. A person is using electric iron, or maybe somebody is using fridge or freezer or something. Someone must be using something different, or washing machine and all that. So meaning that everybody is providing a form of resistance. Someone is providing different form of resistance. So all this actually boils down to what resistance is all about. So resistance is the opposition to the flow of electric charges. So you take note of that important point. So because of this now, I'm going to state that even the bulb, which serves as a load, can also serve as a resistance to the flow of current. So now resistance, when we are talking about resistance now, say it's the opposition to the flow of electric charges. So it's represented as arrow, and it is in ohms. So the unit of resistance is ohms. Now we have two ways that we can arrange resistors. Resistors can be arranged in series and they can be arranged in parallel. So we can have series connection, resistors in series, and we can have resistors in parallel. So we have series and we can have parallel. Now this is how series connection works. Now in your house, for example, you will observe that there are certain bulbs that if you just click on the switch, you just switch on the bulb like this, you observe that three bulbs will just be switched on the same time. While there are some situations where if you switch on the bulb, you observe that only one bulb is on, while the other one needs another switch so that it will be on. So that's what differentiates series and parallel. Series connection, they are all in the same line and the same electricity flows through all of them. Parallel connection, not the same current flows through all of them. Current tends to branch into different units, different compartments. Now this is how series connection works. So if we have this, if we have series connection like this now, something like this now, this is arrow 1, this is arrow 2, and this is arrow 3. So if this is series connection now, this is our series connection now, we can say that arrow T equal to arrow 1 plus arrow 2 plus arrow 3. So in series connection, this is what we have. So from here we can say that if, for example, we have something like this now, we have this connection like this. Maybe here we are having 2 ohms. You know, it's ohms we're working with. Yes, 3 ohms. Then yes, 4 ohms. So our arrow T is going to be equal to arrow 1 plus arrow 2 plus arrow 3. And it's going to give us 2 plus 3 plus 4. 2 plus 3, 5. 5 plus 4, 9. So we're having arrow T to be 9 ohms. So that's what occurs here. Then for parallel connection now, let's say this is in parallel. Parallel connection is going to be in this form. We're arranging in parallel. So we're having this, and this is what we're having. So if we're arranging in parallel, we're having something like this, and this is arrow 1, this is arrow 2, and this is arrow 3. So if we're arranging in parallel, this is what we're going to have. We're having this. So from here in parallel, your arrow total, which is your equilibrium or equivalent resistance, is 1 over arrow T equal to 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. So this is what we're having. But note that we are looking for arrow T. We're not looking for 1 over arrow T, but rather we're looking for arrow T. So let's have this example. Let's say we are told, look for the equivalent, find the equivalent resistance in this arrangement, this parallel arrangement. Let's say we have something like this now. Okay, so we have something like this in this form, and then we're having here to be 2, we're having here to be 4, and we're having here to be 2 ohms. So how do we go about it? What we just do, 1 over arrow T equal to 1 over arrow 1 plus 1 over arrow 2 plus 1 over arrow 3. So this is giving us 1 over 2 plus 1 over 4 plus 1 over 2. So the first step you are going to take is we are going to first of all find our LCM. So what is the LCM of 2, 4, and 2? That's the first thing you are going to ask yourself. The LCM of 2, 4, and 2 is 4. 2 into 4 is 2. 2 times 1, 2. It's still your knowledge of mathematics. 4 into 4 is 1. 1 times 1 is 1. Then 2 into 4 is 2. 2 times 1 is 2. So from here, we're having 1 over ROT equal to 5 over 4. 5 over 4. But this is not our final answer. We're still going to come here again. And we are going to say, we are going to do, let me write this again, 1 over ROT. Then we're having 5 over 4. So this will go up. This ROT will go up. Then 1 will come down. Then 4 will go up. Then 5 will go down. So we're going to have ROT. That's, it's going to be ROT over 1. So now I have ROT equal to 4 over 5 ohms. And this is our answer. ROT equal to 4 over 5 ohms. Or this is supposed to be 0.8 and 0.8 ohms. So whenever you have in parallel connection, if you have 1 over ROT equal to maybe 1 over 2, for example, ROT will go up, then 2 will come down. You understand? So that's going to give us what now? If it's 1 over 2, for example, 2 is going to go up. So that's going to give us 2 ohms. If, for example, we have 1 over ROT equal to 1 over 2, we'll just say 2 will go up, ROT go up, and the 1 will come down. So this is giving us ROT equal to 2 ohms. You understand? Take notes. Don't write 2A. It's not 2A. Don't write 2V. It's not V. But rather, the unit of resistance is what? Ohms. So that's what occurs here. You take note of this. Then another aspect we are going to look into now is we are going to see how we are going to harmonize or improve on our knowledge of series and parallel connections. Now, these are series connection again that we drew before. This is the series connection we drew before now. The series connection we drew before. Now, in this series connection, I'm going to develop it more. So this is R1, this is R2, this is R3. Now, for this series connection now, we're going to connect a voltmeter here, V. I'm going to connect a voltmeter here, connect another voltmeter here, this is V1. Connect another voltmeter here, V2. Then we're going to connect another voltmeter here, V3. So now this is what we are having. Then this is for series connection. Now this is for series. So you observe this for series connection. Now we're going to do the same for parallel connection. So for parallel connection, these are parallel connection is parallel connection. So parallel connection like this, and to do it like this and like this. Now, okay. So this is R1, this is R2, and this is R3. So now this side we're having IT. Here we are having IT. Here we're having I1. Here we're having I2. Here we're having I3. Then here we are coming here and we're having a voltmeter here, VT. Now, okay. So observe very well. If you look at the series, and this is parallel connection now. In series connection, what do you observe? In series connection here, we can observe one core thing. We have R1, R2, and R3. Then in series connection, we have V1, V2, and V3. But here we have only one current, which is IT. So one current flows through all the resistors. That is the first thing. One current flows through all the resistors. So from here, we can say that in series connection, like I said, when you click on the switch, you observe that all the resistors or all the bulbs are on at the same time. So that means in series connection, we have same current but different voltage. So series connection, in case they ask you, series connection has same current flowing through, same current, but different what? Voltage. Now you observe that we have V1, V2, and V3. So that's the first thing. So we can say this. Then for parallel connection, we have different current. You observe that IT now came here. IT came to this point, but at this point, it branched to give us I1, I2, and I3. And you know one core thing we can say, IT is equal to I1 plus I2 plus I3. IT equal to I1 plus I2 plus I3. So in this parallel connection, now we can state something very clear in parallel connection, same way we stated in a series connection. In parallel connection, we have same voltage but different currents. Same voltage but different currents. Take note of this information. So in parallel connection, we have same voltage and different currents. And in series connection, we have same current but different voltage. Take note of this information. So we are going to proceed now to the next part. I want to proceed to the next part now. So let's see how we progress right away. So first things first. Let's say we have a question in this form. Let's say we have a question in this form. Now they told us to find the current in the 12 ohms resistor. Told us to find the current in the 12 ohms resistor. So let's see how we can go about this. Find the current in the 12 ohms resistor. Okay. So okay. Let's see how we go about this. 12 ohms, 4 ohms, then 2 ohms. Now they told us find the current in the 12 ohm resistor. Now in this aspect, you take note that, like I said before, we have same voltage, then we have different current flowing through. So if they are telling you now find the current in this, the current in this is different from the current in this and the current in this. So how do we find it? You take note that V is equal to I arrow, like we did in Ohm's law somewhere around here, where we said that V equal to I arrow. You observe this V equal to I arrow. So if we have this now, for us to get the current in this 12 ohm resistor, we'll first of all make I the subject of formula. So we'll divide both sides by arrow. You observe here V equal to I arrow. So divide both sides by arrow. So from here we can get that V over arrow equal to I. So if V over R equal to I, we're talking about the 12 ohm resistor. So the voltage here, we have same voltage. So that means the voltage does not change. So we can just come here and say I equal to 12 over R here, which is also 12. So if we divide 12 by 12 now, what is it going to give us? 1. So we have 1.08. 1.08. Or if maybe this is just for 12 ohm resistor, now they ask you for 12 ohm resistor. What if they ask you what is the total current? How will you find total current? You always remember this important information where I said in parallel connection, you tend to use 1 over ROT equal to 1 over RO1 plus 1 over RO2 plus 1 over RO3. So this is giving you 1 over ROT equal to 1 over RO1 plus 1 over RO2 plus 1 over RO3. Now what is RO1 here? 2. 1 over 2 plus 1 over 4 plus 1 over 12. And the LCM here is 12. So we're having 1 over 12. 2 into 12 is 6. 6 times 1, 6. 4 into 12 is 3. 12 into 12 is 1. 1 times 1, 1. So we're having this is going to give us 10 over 12. Now, are we going to use 10 over 12? No, we are going to turn it upside down. So we're having this, and then we're having this and this going up. So we're having ROT equal to 12 over 10, which is 1.2. Now, if we're having 1.2 as ROT, if they told you to find the current in the whole setup, you will just say V equal to I arrow. You will divide both sides by arrow, and we're having I equal to V over arrow again. Then the V here is 12. We divide 12 by 1.2. What is this giving us? It's giving us 10A. So if they told you to find the current in all of them, you just use, you resolve it, then you find your current. Or you can just say 12 divided by 12, 1. 12 divided by 4, 3. Then 12 divided by 2, 6. So 1 plus 3 plus 6 is still going to give us 10. So any of the formulas you use will always give you the answer you need. Then this last one here, which I'm going to solve. In this one now, they said determine the current supplied. So let's check this one out. Determine the current supplied here. So so let's try this one out and see. So instead of determine the current supply here. So first things first, just observe this circuit diagram here. You observe that we have 2 and we have 6. That means these two, they are in series. Then the series is now in parallel to this. So series and parallel. So you have to resolve in series first. Then you now resolve in parallel. So you find the current, the current supply. So from here, you first of all say 4 plus 2. Because you know RT equal to R1 plus what? R2. So 4 plus 2 is giving us 6. So indirectly, we have resolved this. Now, this is what is now giving us parallel connections, 2 parallel connections together. We're having 6 ohms here. We're having 6 ohms here. So we are now having this 6 and 6. So 1 over RT equal to 1 over 6 plus 1 over 6. The LCM is 6. 2 into x is 6 to 6 is 1. Then 6 to 6 is still 1. So we're having 2 over 6. So if we have this now, we can say that 2 here 1, 2 here 3. 1 over RT equal to 1 over 3, goes up, comes down, goes up, comes down. So we're having RT to be equal to 3 ohms. Now, remember V equal to I arrow. So if V equal to I arrow, we can say 12, this is 3I. So we divide by 3, and now we can say I equal to 12 over 3, which is equal to 4A. You understand? So from here, we're able to get 4A. So take note of this. Take note of this. Then in this kind of question, let's say we have something like this now. You will take this one as assignment. So you take something like this as assignment. So you try this one out and you can send me your resolution at the end of the day. So let's say we have something like this now. Let's say here's 2 ohms, here's 2 ohms, here's 3 ohms, here's 4 ohms, here's 4 ohms. Now, in theory, you resolve this. Now, you see this is parallel, right? This is in series, this is in parallel. Now, to do this, you just first of all resolve this parallel to series. That means 1 over 2 plus 1 over 2 equal to 1 over RT. So that's giving us 1 over 2, 1 over 2, 1. 1 over RT equal to 1. So if we still take it up again, RT is still equal to 1. So now you now take this down to parallel to series. So we're now having something like this at the end of the day. And we're now having something like this again at the end of the day. So if we get 1 here, for example, and here is 3, and here now that's 2 over 4, and 2 over 4 will now give us 1 over 2, and this will still give us 2. Then we'll now add them in what? In series. 1 plus 3 plus 2. What is it going to give us? 6 ohms. So our total resistance here is 6 ohms. So just try to do this yourself and we'll proceed.